All right, everyone, let's talk about your specific heat lab. So here's the front of the lab. This is the lab that you guys completed the last time that we were in class. To refresh your memory, you took a hot piece of metal and you heated up that metal in a hot water bath. And so you take that hot metal and you put it in a cool cup of water. So you had your styrofoam cup of water that had cool water in it. And so here, first you've got the mass of your metal here, and then you calculated what was the mass of the water that was in your foam cup. Then you took the initial temperature of your water that was in the foam cup. So that's the initial temperature that the water starts out in the cup. Now, then you took your metal and you put it in the test tube in the boiling water. So this temperature right here is the initial temperature of your metal. You only use that boiling water in order to heat the metal. So we don't care about that water there. What we want here is this is the initial temp of the metal. So that was that high temperature of the metal. It should have been somewhere around 100 or somewhere around there for your experiment. Now you put the hot metal in the cool water, and this is the temperature that they both should have reached when they came both to the same final temperature. So the water in the cup, its temperature should have risen, and the metal temperature should have fallen. So this temperature should be somewhere between the initial temperature of that water and that initial temperature of the metal. So let's figure out how to do those calculations. So for this first one, you have data from your trial. So this is the one that you did for your experiment. The data from another group, you need to get that data from someone else who was in a different group. So when you come to these calculations, you're going to divide this section in half, and you're going to do two sets of calculations. One set of calculations for your data, and then over here you're going to show the calculations for the data for the other group. Now what you end up doing is this. So it says calculate the specific heat of the metal. We're going to follow as an example exactly what we did in our notes last class. As a refresher, we said the Q of the metal equals the Q of the water. What that means is we took the hot metal, we placed it into a cup of cold water, and the temperature of the metal fell and the temperature of the water rose until they reached the same temperature. So the heat that was lost by the metal was all gained by the water. Since you did that experiment in a styrofoam cup, all of the heat from the metal was transferred to the water. So their Q values are equal. Now if you remember, Q equals MC delta T. We said originally the heat of any substance equals its mass times its specific heat times its change of temperature. So if we look at this equation and we plug it in, the Q of the metal, we could rewrite that to say the mass of the metal times the specific heat of the metal times the change in temperature of the metal. So I rewrote this Q as this because Q equals MC delta T. And I'm setting that equal to the Q of the water because all of the metal heat was transferred to the water. So the Q of the metal, the heat of the metal equals the heat of the water. I can rewrite this side of the equation, the Q of the water, the same way with its mass, water's specific heat, and water's change in temperature. So I'm going to write here mass of the water times specific heat of the water times delta T of the water. So these equations I put up here to show you how you derive this is the equation that you're actually going to solve. So now you don't need this one and this one. I'm just put that there to show you how you're going to solve this equation. So when you look back at your data, you have the mass of your metal that should be right here. Specific heat of the metal, this is what you're solving for, and so I'm going to put a question mark there. change in temperature of the metal. So the metal started at this high temperature, and then it fell at the end after you put it in the water bath in the foam cup. At the end, it came to a lower temperature. So the difference between these two temperatures is going to be the change in temperature of your metal. So you know this value. Now, you set that equal to the mass of the water. So you look at your data, and here on this line, you should have calculated the mass of the water that was in the foam cup. So that goes here. Specific heat of water. That we know, we've used it in previous calculations. The specific heat of water, C of water, always equals 4.18 joules per gram times degrees Celsius. So this 4.18 is that C that we're going to use there for the water. Now, for the change in temperature of the water was initially a cold temperature in that cup, and you have that recorded. In the end, you have a final temperature of the water and the metal. So you need to take the difference between that initial temperature of the water, which is here, and the final temperature of the water, which is down here. So that's your delta T. So you know all of these values except for the C of the metal. So you can solve for that specific heat of the metal for your data. So you need to put a specific heat of the metal for your data here. You're going to then do that exact same calculation over here on this side with the data from the other group. So you're going to use their mass, their temperatures, and their masses of the metal and the water. So you're going to plug that into the same equation and solve for their specific heat. So you'll have two calculations for question number 1. Now, for question number 2, it says, the metal in the lab is actually aluminum, and it has an actual specific heat of 0.9025. What is your percent error with these 3 significant figures? So, remember, the percent error equation is on your class reference sheet. So this can be found on that yellow reference sheet. So you've got your periodic table. Attached to that is a sheet from first semester. And it will, when you look that up, you will see that your percent error equation looks like this on that form. It said accepted value minus experimental value. And then you take the accepted minus the experimental, divide it by the accepted, and then you multiply that whole thing by 100 to get the percent. So, accepted value is what you should have gotten. This right here is the actual or accepted value of aluminum. So that's the value you put here. The experimental value is what you got and what you calculated up here by doing your experiment. So you're going to plug that value in here. Then you're going to take that difference, divide it by the accepted value, which is this 0.9025. You're going to multiply that whole thing by 100. So you're going to calculate a percent error for this one, for your data, and you're going to do it again for the data that from the other group. So you're going to have to use the specific heat that you calculated from their data. So you're going to do 2% error calculations for question number 2. Now, for the conclusions, it says using the actual specific heat of aluminum. So they gave that to you up here as the 0.9025. How many joules of heat are required? So it's asking you for Q in order to raise the temperature of this. That's a mass in grams, and this is your change in temperature. So you started at 34.8 degrees Celsius and you're increasing up to 42.7. So your equation for this, you're going to use the Q of the metal equals the mass of the metal times the specific heat of the metal times the delta T of the metal. So you're gonna. This is the value you're gonna calculate. You want the heat, which is Q. Your mass is this. Your specific heat, it says use that actual value, And then your delta T, it's telling you the change in temperature here, so take that difference and plug that in. Don't worry about whether it's negative or positive. Just take the biggest number and subtract the smallest. So when you do that, you should get the heat that the metal is releasing. Now for number 2, you're going to do the same thing, but now for water. So use the actual specific heat of water. Determine the heat gained by the water. So it's asking you for Q of the water. When a hot piece of aluminum is dropped inside the water. So the initial temperature of the water is this. The temperature of the metal and the water together is this. So the difference between these two temperatures is your change in temperature of the water. Because the water started here, ended up there. And there's your mass. So the Q of the water is going to be equal to the mass of the water times the specific heat of the water times the delta T of the water. So this is what you're trying to find. Your mass, it says, is, there we go, 36.8 grams. Your specific heat of water, it gives that to you. And then your change in temperature of the water. Just take the bigger number, subtract the smaller, and don't worry about a positive or negative sign. So always take your biggest, subtract your smallest. So you end up getting that change in temperature. So now that's how you solve for how much heat that water gained. And so that's how you do all the calculations for the lab. Go ahead and complete that lab write-up and put it in the turn-in drawer, and I'll see you next class.